so let's pick it up from where we ended. And yeah, so I think this is the last lecture slide I'm using for uh, Morongoshi University because it's a crime to use or I'm sharing someone else's content, which is not okay, which is a crime because I do not own the right to do so. Yeah, but yeah, so I think I'll be making my own um uh lectures lecture slides where I'll be learning. Okay, so we talked about the universal set. So let's talk about the number of subsets of a finite set. So the number of subsets, the number of okay, so is given by so if you want to know how many subsets in a set, you can have that number, the number of subsets, by using this formula. By using this formula, 2 to the power n, where n is the number of elements in such a set, in that particular set. So for example, let me say, maybe if set A has got elements like 1, 2, 3, 4. So the number of subsets in this set is given by this formula. So we're going to say 2 to the power n, where n is the number of elements in set A. So you can say 2 to the power 4, which is equal to 16. So we have 16 subsets in set A. So how do we know that 16, or how can we prove that it's 16? So how do we write subsets? So you know to say set A has got elements like 1, 2, 3, 4. So let's now do so. So we can say uh we have 1, we have 2, we have 3, we have 4, and then we have 1, 2, we have 1, 3, we have 1, sorry, we have 2, 3, we have 1, 2, 3. Sorry, I made a mistake. 1, 2. Okay, so we have 2, 3. We have 1, 4. We have 1, 3. We have 3, 4. We have 2, 4. 2, 4. Then we have 1, 2, 3. Okay. 3. And then we have we close. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we are remaining with 5. So we also have 2, 3, 4. We have 12. Okay, we have 12. So 4 remaining. So we have 4 remaining. We'll have 1, 2. We had 1, 2, 3. Then we also have um, 1, 2, 4. Then we also have um, 2, 3, 4. Then we also have 1, 2, 3. Then we also have 1, 2, 3, 4, the set itself. And then we also have an empty set on our set. So in total, excuse me, in total we have 16. So that's how we make subsets. So for a clear understanding, let me get a simpler set. So let's say set set x set x is equal to 1 comma 2. Yeah, like this. So for you to get the number of subsets in here, you're going to say 2 to the power n, where n is the total number of elements in set x. You'll say 2 to the power 2, which is equal to 4. You get right? Now, how do we know that they are 4? How do we prove that they are 4? So we said set x has got 1 comma 2. So 1 comma 2, so you have subsets like 1, then we'll have 2, then we'll have 1 comma 2, then uh, we'll have an empty set. So in total, if you count them, you have 4. So how do we know if a set maybe had how many elements? Set x or set, we use x, so set y is equal to 1. Set y is a singleton. So how do we know that how many elements, how many subsets does set y have? So you're going to say 2 to the power n, we have 2 to the power 1, which is equal to 2. So how do we prove that it's 2? What we're going to do is we are going to say, since y has gotten 1 element, the subset will be 1 itself and the empty set. So here we have 2. Now, what if set y, or maybe set y, excuse me, sorry, okay, maybe set y is a is an empty set, meaning there is nothing in set y. So we are going to say, how many subsets does this have? So we're going to say 2 to the power n. So 2 to the power 0 is equal to 1 element, 1 subset. And what is that one subset? That one subset is an empty set. So that's it. That's all about subsets. So, okay. Okay, so this is all you need to know about subsets. So we come to classes of sets. A class is a collection, a class or collection or family is a set of sets. So these words, the words subclass, subcollection, subfamily have meanings analogous to subset. Meaning this word means take note of that word, analogous. Yeah. So okay. So we have an example here set. Suppose A is equal to 1, 2, 3, 4. Let A be the class of subset A which contain exactly 3 elements of A. So you've seen how they've written this. They've seen set A. Set A is 1, 2, 3, 4. Then let A be the class of subsets of A which contain exactly 3 elements of A. So we are going to get the first 3 elements, 1, 2, 3. And then you're going to say 1, 2, 4. You remove that number. So we will remove 2 this time. We are going to the left. Okay. So we are going to say 1, 2 won't be. We are removing. If you've followed the pattern, Okay, we have started here on 4. We'll remove 4 first. In the first set, we also remove 3, we also remove 2, we also remove 1. So we start 1, 2, 3. We end a second, we remove 3, 1, 2, 4. Again in the third, we remove 2 here, 1, 3, 4. And in the fourth, we remove 1, which is 2, 3, 4. So that's the pattern. Okay. So let B be the class of subset which contains 2 other elements. So we have B here. You do the same. So 1, 2, 3, 1, 2, 4, 2, 3, 4. Okay. Yeah. So thus B is a subclass of A. To avoid confusion. All right. So let's go to power set. Let's go to power set. So we go to power set. Okay, so for a given set, the class of all subsets of A is called power set of A, and it will be denoted by PA. So a set A, let's say a set A has maybe one, two, two elements, and then you have been told to find the number of subsets. So you say 2 to the power n, which is 2 to the power 4, which is sorry, 2 to the power 2, which is equal to 4. Now this 4 is the total number of subsets in A. Now what are those subsets? Those subsets, since we have A as 1, comma 2, what we'll do is then we'll have um, uh, uh, our subsets will be 1, 2, 1, 2, and an empty set. So this is for now the set of these sets, the set of a subset, meaning this whole set here we've come up with is what we are calling a power set. Is what we are calling a power set. So for a given set A, the class of all subsets of A is called the power set, and it will be denoted by PA. So if you say PA, then they want you to find the power set, and it is denoted by 2 to the power n A. Yeah. So they are saying this is the reason power set, this is the reason PA is called a power set, and it's also denoted by 2 to the power A. So we've been given sets like A 1, 3 and B ABC. So the subsets of A, as you can see, the subsets of A is empty set 1, 2, uh, uh, okay, empty set 1, 3, 1, 3. So here the total number is 4. The total number of subsets is 4 because we have 2 elements, and we've been given this formula 2 to the power n, which is 2 to the power 4, 2 to the power 2, which is equal to 4. No wonder we have 4 here. Okay, so the power set is the set of all the subsets. So this what you can see here is the power set. Yeah, is the power set. So yeah, that's it. That's all you need to know about power sets. Now we come to the Venn diagram. So Venn diagram is just a pictorial or diagrammatic representation of all the sets of the sets. The universal set is represented by the point in a rectangle, and other sets are represented by discs lying in a closed. So this A you can see here is a single tone set. So the universal here uh, denotes or represents all the elements in this uh whole thing. Yeah. So A A is a subset of the universal, and the universal is the superset of A, meaning all the elements in A are contained in the universal set. That's it. So um all the elements that are in A are contained in the universal. So these are the things we learned in at secondary. So not going to waste so much time. So if A is a subset of B, then the disk representing A will be entirely within disk B, meaning if A is a subset of B, meaning if every element in A is contained in B, then the disk that is encompassing or that is containing all the elements in that in it will be encompassed by disk B, which represents that or which says that all the elements in A are found in B. Okay. If A and B are disjoint, meaning they have no element in common, meaning there is no intersection. There is nothing here like the way we used to we drew what's this? Maybe let me see. All right. Okay. We had sets. We are used to sets which are drawn like this. These are these are joint sets because they have something in common. Like I said, they have something in common. But when sets when sets have nothing in common, they are disjoint. They can't be attached. There is no point of intersection between them. So you write them like this. For example, what you're trying to say here is um if you have set A, which is 1, 2, 3, and then set B, which is 5, 6, 7. When representing these sets on a Venn diagram, they won't attach anywhere because the elements in A are different from the element. There is nothing common between the elements in set A and the elements in set B. Therefore, the sets are said to be disjoint. However, if we had something like A having maybe A, B, C, D, E, and then B having something like A, E, O, O. Okay, so when representing these in a Venn diagram, you'll have something like this. You'll have something like this. And what will be contained here on the middle there, you have these elements which are in common, A and E. A and E because they're in common, meaning these are joint sets. Yeah, so that's it. Okay, so on the other hand, if A and B, okay, so this is just the opposite of what I was explaining here. So we come to the operation of sets. We come to the operation of sets. So we now define the method of obtaining new sets from given ones. So um we start with union of sets. So let A and B be non-empty sets and U be the universal set. So the union of A and B, denoted as A union B, is the set of all elements which belong to either A or B. So this is just a combination of A and B. For example, if we have a set, all right, okay. So if we had set A as 1, 2, 3, 4, then we have set B as A, B, C, D. So when they ask you to find A union B, what they're trying to say is combine A and B. So the order doesn't matter. If you want, you can say 1, A, 2, B, 3, C, 4, and so on and so forth. So the order doesn't matter, but I would advise you write in order so that your work can be neat and can be difficult. It can be simple or easy for the marker to see. And then one thing you need to know is you when dealing with union, you don't repeat uh, members. For example, if in B we had one, or maybe let me say if we had 2, 4, 6, 8. Just because 4 and 2 are also found in set A doesn't mean you have to repeat them twice when writing A union B. Just list them once. So you say 1, 2, 3, 4, 6, 8. You close. So that's it. That's it. Yeah. So that's all about the union. That's all about the union. And the diagram, the shading. If they say represent union in a in a Venn diagram, you do this. This is how you represent it. So you shade everything. You shade everything. Okay. Let me do this so that you notice the difference in shading. Okay. Okay, so this is your A, this is your B. So that's how you shade, and then this is the universal outside. Okay, so that's all about union. Okay, okay, so this is what I'm talking about. So they have given us an example here. They have given us an example. So let the union set be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then let A be 1, 2, 3, 4. And then B be 3, 4, 5, 6, 7, C. Okay. Then find A union B. So find A union B. So A union B will be equal to. So if we look at A and B, we'll say 1, 2, 3. So I'm going to write 3 just once. Just because 3 is found in both A and B doesn't mean I have to write it uh, more than once. Okay, so even 4, I'm just going to write it once, and then 5, 6, 7, and then I close. If you look at my answer, it's this answer we have here. So that's it. And then they say A union C, meaning combine this and this. So you're going to say A, okay, let me just write it here. A union C is equal to 1, 2. So I'm going to say 1, 2, 3, 4, 8, 9. So if you check this answer, this is the answer we have here. So you also do the same for this one. Okay, so that's it. So we proceed. So let you denote the set of students at a university. Okay, so and let M and F denote respectively the set of male and female students. So then if you combine, what they are trying to say here is that let you denote the set of students at a university. You know that there are two sets of people. In this world, we only have males and females. So when they say male union female, then we'll have the universal. We'll have the universal. Yeah, we'll have the universal. Yeah. Okay, so let's proceed. We go to intersection. Intersection is represented by this uh, symbol which looks like a small letter N. Okay, so when they say intersection, what they're trying to say is find what is common. For example, if this is A, then we have A, we have 2, 4, 6, 8. Then we have B, we have 1, 2, 3, 4. And then when they ask you to say find A intersection B, you just look for what is common. So we have 2 in here, we have 2 in here, we have 4 in here, we have 4. So you just say 2 comma 4. And that's it. 2 comma 4. You are done. So just finding what is common there, then you are done. So the diagrammatic representation or Venn diagram representation is here, is now. Okay, so this part is the intersection where you will find elements which are found in both A and B. That's it. Okay, yeah, so that's how we go about it. Yeah, so A intersection B, meaning X is a member of A and X is a member of B. Yeah, and so take note, for intersection we use and, we use and. So intersection goes with and then union goes with or. So take note of that. Union or, intersection and. So they might not use these symbols, they might use these words. So take note. Okay. Okay, so this is the diagrammatic representation of intersection. So if A and B are disjoint, then A intersection B is equal to an empty set. What I'm trying to say is, if there is nothing common between A and B, then A intersection B is an empty set. Is an empty set. Okay, so we proceed. If we've been given this as our universal 1 up to 10, then we have set A 1, 2, 3, 4, then set B, and then if they say find A intersection B, you are going to look for common elements between A and B. So what are the common elements? We have 2 here, we have we have 3 here, we have 3, we have 4 here, we have 4 here. Okay, so if A intersection B, so you just say 3 comma 4, then you are done. So this answer is the same answer they found here. Okay, so for A intersection C, just look for what is common between A and C. So you see that 2 is common, even 2 is here. 3 is here, even 3 is here. So you say 2 comma 3. So my answer here is what they found. So that's how we go about it. Okay. So let you denote a set of students at a university and M, F denote respectively the set of male and female students. So there is nothing common between males and females. There is nothing common. We have different. Okay, everything is different. The way we talk, the way we should act, biologically we are different, and so no wonder it is an empty set, because there is nothing common between males and females. We are two different types of people. Okay, complement of a set. Complement of a set. So let A be a non-empty set and U be the universal set. The complement of A denoted by AC. So complement can be denoted by A, C, or A prime. B, C, or B prime. So don't be confused. These two are the same. Okay. So meaning, if they say find a complement of set A, they mean find the set which contains all the elements except those which are in A. So I talked about the universal. So you might have maybe set A. Okay, you can have set A as 1, 2, 3. Then B, you can have set B as 2, 4, 6. Okay, so the universal will be 1, 2, 3, okay, 4, 6. So this is the universal, the combination of these two. Okay, combination of these two. So if they say find a complement, what they are trying to tell you is in this set, universal set, remove everything that is in A. So what you are going to do, you are going to cancel this and then write what is remaining, which is 4, 6. Then this becomes your A complement. Okay. Now, what if they ask you to find B complement? Okay, B complement. What they are trying to say is in the universal, remove everything that is in B and write what is remaining. So you are going to cancel this, this, and this, meaning your B complement becomes 1, 3. That's all about B complement. Another example, we have the universal as U is equal to A, B, C, D. 1, 2, 3. Then we'll set A as A, B, C. Then set B as, okay, we'll set B as 1, 2. So if they say A complement, just go to the universal, cancel all the elements which are in A, B, C, and write the rest. So you have D, 1, 2, 3. This becomes your A complement. Now, what if they asked for B complement? If they ask for B complement, then what you will do is you write this B complement. Just go to the universal, cancel all the elements in B and write the rest. So you have A, B, C, D, 3. That's it. You're good to go. Okay. So this is how we represent a complement in a Venn diagram. Shade the outside and leave A. Okay, so we have been given an example here. They say let U be equal to ABC, the letters of English alphabet, and then they say find A complement. If A is this, so if we have something like this, you see that the letters of the alphabet, the 26 letters, and then they say find, and this is A, this is B, this is V, so if they say find A complements, just come in here, cancel all the letters or all the elements in B, cancel them, and then write all the elements in A, sorry, cancel them and then write what will remain. Yeah. So if you write what remains here, okay, that will be your A complement. So that's how we go about it. All right. So let me reach 35 minutes, then I'll stop. I have to make another video. Okay. From the next video, start from the relative complement. Okay, guys. So this marks the end of the second lesson. Don't forget to subscribe to my YouTube channel, hit the like button, and share the link to many. You only support this by liking and subscribing so that I create more videos for you. Yeah, so if you enjoy my videos, if you enjoy what I'm giving you, if you like them, then I'm asking for you to subscribe and like. That's the only way you support me. That's the only way you show me that you like what I'm doing. You are supporting my work. So subscribe, hit the notification bar so that you'll be notified every time I have uploaded a video for you. Thank you very much, and God bless you.